Hello, I am Garrick in mechatronics, and for the 2026 Capstone, I'm doing a proof of concept for an idea I've had for a long time of a smart bench that is capacitive touch on the top to help streamline the ideas of creating new products and showing them off to consumers. When I first started researching the Capstone, I found this wonderful website called Multi-Touch Kit by HCI, which I'll link in the description, that shows a microcontroller like the Pi Pico, using two multiplexers to control a small grid of conductive lines like this to be able to read capacitance and show off on a grid where you're touching it. The first step to making this project was connecting just one line. This long one you see here was the first one I made, to the Pi Pico. The Pi Pico would send a signal about 3.3 volts, I believe is pin high, and then read it using analog just a millisecond later, and I would see the difference of what it read back versus what it sent. Usually a very small difference, like 3.3 volts to 3.1 or something like that. But then when I would touch it, I would send the signal and read back a way lower signal because my finger, any skin, has the ability to store electricity. So the electricity would go in here and go into my skin, and then it would read it back, and it would have lost electricity that it sent. The next step uses this to then read the line continuously thousands of times a second, and then as soon as I touch it, just a millisecond later, it would be able to tell me in the terminal that it was being touched. This takes us to the third step, where I can make a full grid using two multiplexers, which use just 5 digital pins to get 16 analog pins, which is great because I only have 3 analog pins, and you need analog to be able to read differences in voltage rather than on or off. So then I was able to connect one multiplexer here and one here to read a 5x5 grid, giving me 25 touch points. So I could touch here and it would know because the capacitance was lower than it should be when it read it back. So I could touch here and it would know that X1 was being touched at the same time Y1 was being touched, and be able to tell me that I'm on the bottom left of that grid. This is great for step 4, where I introduced HID, like I explained before, to control it as a mouse, which is great because I already have experience with that in previous projects, so I was able to just take a lot of the code that I had already done before and put it into this new one, identifying as a mouse. So then it's sending the X and Y signals that I've already put in here for my terminal reading as mouse commands. So when I put here, it takes my mouse to the bottom left of my monitor, and then here top right, and so on and so forth. Which then takes us to the final step, where I can get the full desk of conductive copper lines and wire them to 4 multiplexers, which only takes 20 pins in the microcontroller, but gives me 64, so I can have 40 X pins and 40 X lines and 24 Y lines, giving me almost 1,000 touch points, which is a much higher resolution for an actual PC mouse. So here's a video of it working. So as you can see, when I touch here, it takes a second, but the mouse is going to move to the bottom left corner. It takes a while because the multiplexer is reading all these lines one at a time. In the middle.